Welcome again to the Toolbox podcast, and this is the second day of Obvious in Uganda. Just again to introduce Obvious. Obvious is the technical and training manager of TOA Africa, both South Africa and in Africa. What did you say today morning? It's not training, it's what?
Discussion.
No, you...
Interaction.
No, you called it something else. It was interesting.
Thank you.
I don't train people, I share with people or something.
That's correct, yeah. I don't believe that I'm training, I'm sharing of knowledge, passing on of knowledge.
Yes.
Awesome.
So the Toolbox podcast, as my co-host Peter always say, a good consumer is an educated consumer. So I thought today we'll talk about few things besides just TOA advantages, but also some basics. And to start, because it's all about sound and TOA is all about sound and communication, how do we help a consumer to buy a speaker and to know if that speaker is better than that speaker without listening, without seeing the speaker on the paper? So I go to Amazon, I go to online, I go to websites of Bosch, JBL, Bose, TOA, and all of them. How do I compare that this speaker is better than this one? What are the things, what are the parameters you need to look? And before we even start, in Africa, the perception is that the bigger the better, the more watts, the better. And yet, when I start first engaging with TOA, I was told that this is wrong.
Yeah.
And TOA is actually well known worldwide for the most power efficient speakers in the world. So ever since then, we actually educate people and tell them, when you look at speakers, the last things we care about in speakers is the size and the watts. Those comes last. We don't care about them at all.
Correct.
So what are the few things you need to look into a speaker when you want to buy a speaker?
Right. You mentioned quite importantly some other stuff that we normally do tend to look, oh, it's a big speaker. Yes, it looks, you can hang it up on the roof, on the ceiling. Okay. So yeah, we need to look at the specs of the speaker. There's something called SPL. So we talk of a speaker outputting sound. Well, basically measured, done over 1 watt of power into the speaker. You're standing 1 meter away from the speaker. This is what we call SPL measurement. So some speakers are rated 94 dBs, for example. Some are 105, like our TOA 10 watt one speakers, the SC610M. It's rated at 110 dBs, 1 watt of power into the speaker, 1 meter away from the speaker. That's a lot of sound. As you mentioned, Africa has a different perception. We always think, oh, a big speaker produces much sound. No. We did a simulation sometime in Johannesburg at a car shop that sells cars. I won't mention the name. But what they had been quoted a lot of horn speakers. And we went there to the client. We said, no, you don't need. We only need a few of them, maybe 5 to cover the whole space. He was like, no, I need more. And we just connected one of our horn speakers, tapped it to 1 watt, and we cranked up the volume from our amplifiers. Like, no, it's too loud. So exactly, 1 watt, 1 meter away at an SPL of 110 dBs. That's a lot of sound. So you need to look out for what is the SPL rating of that speaker. You can even connect a TOA speaker, for example, ceiling speaker rated at 94 dBs, for example, 1 meter, 1 watt away. You can connect that speaker and tap it down to 3 watts, for example. With the competition speakers, you might to come to the same SPL as my TOA speaker. Your speaker might be needed to be tapped at 30 watts to produce the same SPL that I would get from a 1 watt fed into a TOA speaker when I'm standing 1 meter away.
Now, SPL, for those who don't understand anything in sound, what does SPL stands for? And sometimes when you go in the specs, it's not SPL, it's sensitivity.
Correct.
Elaborate the two. What is SPL versus sensitivity and vice versa and so on?
All right. So SPL basically is how a speaker outputs sound in terms of dB, the sound pressure level that comes to your ear in terms of dB.
SPL stands for sound pressure level.
Yes. Just in a nutshell, in simple explanation, how much a speaker drives out power when you input a certain wattage. So standard industry standard says when you put in 1 watt of power and you are standing 1 meter away, that what the speaker drives out is what we call the SPL. So they have got different ratings. So in my, for example, if my TOA speaker is rated to 94 dB of SPL, 1 meter, 1 watt away, 1 watt away, 1 meter, that means that speaker can drive that 94 dBs of power. Okay. But other speakers, for them to achieve the 94 dB as my TOA speaker, you might have to tap your speaker at a higher wattage to then compensate to give you the same SPL as my TOA speaker. Where it ends up at the end of the day, TOA speakers are known for being very efficient. For example, in a hospital application, in the hotel rooms, I can tap my speaker at 0.7 or at 1 watt comfortably and still achieve the same SPL that is required by the person who's sitting on the bed. But other speakers from other manufacturers, depending on how they are done, you might need to have that speaker at 3 watts. So that's the difference in quality of a TOA speaker, standard TOA speaker.
And sensitivity?
And sensitivity, let's say it's more one and the same. It's just the same. It's just the same, but explained differently by different products.
And when we talk about cheap products,
yeah.
And this is where you always need to be careful and this is all about attention to details.
Yes.
Because you'll find some manuals or some spec sheets that will tell you at 1 watt at half a meter or at 5 watts at 1 meter.
You are right.
So we just advise our consumers, just pay attention to the comparison.
Yeah.
Also, there is all sorts of very funny things marketing. There's like PMPO.
Oh, yeah.
And peak power.
Yes.
So people just need to be careful. What you need always to find in order to compare apples to apples or the right product to the right product, what does it give you at 1 watt at 1 meter?
Yes.
If they give you something else, you need to try and dig.
Yes.
Because sometimes they hide it.
All right.
You need to try and dig to find it out so you can compare the product to have the right output.
But you mentioned something very, very common. When I was still young in the industry, we used to see these imports coming through, a Wi-Fi speaker written 1500 PMPO. And it was like, wow, now I've got this, I can do a disco in my house. But peak music power output is not the real power of that speaker. We're looking at a fraction of a second, if I may say, where that speaker can handle that high power and then it goes back to normal. And you open up the speaker, we had an argument, and then the guy was like, no, this is 1500 watts, peak PMPO. We have an argument, we open up the speaker as technicians, we look inside the speaker. It's written 50 watts, 8 ohm 50 watts. And then the box and the housing is written 1500 PMPO. So they are looking at that fraction of a second where the spike can go up, but definitely the speaker cannot handle that much more. So it's just a marketing
So just for the consumer to understand, PMPO, which is a lot. We even been to a church recently.
Oh, yes.
I showed, I don't remember who was there, the PMPO sticker on the speaker. What it means is that can do 1000 watts for 1 second.
Yes.
More than 1 second, the speaker goes boom.
Boom. That's correct.
So this is marketing gimmicks that lots of companies do just to make you, this is big, but it's actually a small speaker in.
Spot on.
Then we have in sound also something called RMS and continuous. There's a lot of confusion in sound.
There's a lot of confusion.
What is RMS and continuous sound or continuous power?
Again, without going to the technicalities, it's called root mean square value of the speaker. Okay, I would put it as like average value of what the speaker can handle. And then we've got continuous RMS, which is absolute power that the speaker can handle over a period of time. So without going to the mathematical ones, like I've said, one will not use maybe root mean square value because then when he puts out his speaker, it's like, it's only 300 watts, for example. And when I use PMPO, it's 1500 watts. So it's just most manufacturers now, especially of hi-fi components at home, your hi-fi sound systems, they will never write in RMS. They normally go for PMPO just to drive you to say, this can handle 2000 watts of power, but it's PMPO. But in real value, probably it only handles 50 watts or 100 watts of power.
So I'd rather go on than RMS. I go with continuous. Which one do I go with?
I prefer technically speaking, I prefer the RMS value.
Okay.
Yeah, or the continuous program is what the speaker can handle over a long period of time without getting damaged.
I also just remembered some manufacturers even put max SPL.
100%.
So the max, you always need to do calculations down and see what is the real, because some will give you, this speaker is 120 dB, but at max SPL. What does it give you at 1 watt at 1 meter? So you always need to look,
yes,
what do I really get in order to compare?
correct.
Beside SPL, when we look at the speaker, what's the other things I need to look at?
Application use. What is it designed for?
But in terms of specs, when I look at the spec sheets, I think after SPL comes frequency response.
Of course.
What is frequency response?
Frequency response, our humans, when we speak in a certain frequency spectrum, okay? The lower the frequency numbers that the speaker can handle, the more the bass it can play, and the higher the frequencies that it can handle, the higher the tones, the high frequencies it can handle. For example, a subwoofer can be written maybe, for example, just for argument's sake, 200 ohms, all right? It's you cannot play a rhythm guitar through a subwoofer.
200 ohms or 200 hertz?
200 hertz. Thank you for that. 200 hertz. So you cannot play a rhythm guitar and have the sound coming through a subwoofer. It's not designed for that. It's supposed to handle low hertz, low frequencies of your audio spectrum. So a subwoofer pushes the doof, doof, doof sound that you hear. That's low frequencies. Your tops, your mids, your sopranos, if you are in a choir, they are on the higher side. So the lower the frequencies that the speaker can do to the higher the frequencies, we can call it, it's a universal speaker that covers all the frequency spectrum. Let's take an example for a horn speaker. I've heard people asking in our designs, I need a horn speaker. Okay. We ask them, what do you want the horn speaker for? They tell you, no, it's just going to be in the basements of our building. And guess what? When you come to site after some time, you are looking, but they are playing music through the one speaker. And then they say, but TOA speakers don't sound nice. Well, a normal SC one speaker from TOA is not designed to broadcast music. It's much more for a voice lift. Okay? So if you want music in your basement, we'll give you a different type of speaker. So people don't look at the frequency in hertz of what that speaker can handle. So if I want music to be played in my basement, I will not use a TOA horn speaker. I will use a TOA musical horn speaker that can handle some decent low frequencies all the way up to the highest frequency.
And we have those as TOA.
We do have. The CS761s, I believe. Yeah, we do have.
Yes.
Yeah.
You mentioned applications.
Yes.
Many people, when I ask in Uganda, so what's the application? What do you mean? What is application?
Yes.
So we try and tell them, is it for speech?
Yes.
Is it for background music?
Correct.
Is it for foreground music?
Yes.
What is foreground music?
Correct.
People don't know what's foreground music.
Correct.
Even me, I didn't know. I had to ask Ralph at some point. What is foreground music?
Yeah.
That is the loud music.
Yes.
The opposite of background music.
That's true.
Then we have live band.
Yes.
We have evacuation.
Yes, correct.
And then we have the oomph.
Yes.
Which other applications are there? Or I covered them all?
You did cover them. It's basically two, foreground and background. Let's explain. Background is music that you can work with comfortably. We can still do our conversation. We can still answer our phones. We can still work. Foreground music, if you phone me when I'm in front of my favorite artist, forget it. I'm not interested. All I'm doing is paying attention to what's happening on screen, and I'm jiving. So that's foreground music. So you've split it up quite nicely.
Okay.
Yeah.
And then I think the third thing when you specify a speaker is impedance.
Oh, yeah.
Before the watts and the size and the rest.
Yes.
So it's first SPL, stroke sensitivity.
Right.
We follow to frequency. By the way, in frequency, the most common term in Africa, I want a full range speaker.
Oh, yes.
So when somebody says full range, it means the full range, the full spectrum
Yes.
of the frequency.
Yes.
And when we talk about frequency, by the way, sometimes you can get a subwoofer that is fit for this application.
Right.
And this is, you see in the frequency, even if you're not a sound man,
Yeah.
you need to see, and frequency, by the way, the full spectrum is from 20 hertz to 20 kilohertz.
Yes. Correct.
This is when you have a full range. And to compare, again, just on paper, first you need to see the frequency, then the SPL,
Correct.
and lastly is the impedance. Why is the impedance so important?
Oh, that's a whole drama. So amplifiers are rated out at different impedances, all right? So the most common across the industry is the 8 ohm impedance loads. Then you do have speakers that come in 8 ohm impedance. We call them low impedances or low impedance speakers.
Or low Z.
Yes. And then or low Z, correct. And then we have also some speakers that are rated as 4 ohms. So what happens is on a low impedance amplifier, the load and the amplifier must match. If it's an 8 ohm load, okay, which is your speaker, your amplifier should produce 250 watts, for example, at 8 ohm. When you do a mismatch of the impedance, you're asking for trouble. Whereas on the 100 volt output, which is our voice alarm system, for example, our public address systems, for example, the impedance there is not much as critical as you would. What is critical on the high impedance side is whatever is your load must equal to or less than the amplifier power. Whereas with low impedances, number one, it's not just the sound that you're driving. They produce a lot of power, current, from the amplifiers directly into the speaker. There's no transformers to block that sound that we were talking about when we were doing the 100 volt principle yesterday, where on my amplifier, I've got an amplifier, superimpose my voice on 100 volt. 100 volt carries through my signal to the speaker. The speaker does not like voltage, blocks my 100 volts, allows the voice to go through. So on low impedances, 1:1. If your 500 watt amplifier pushes power to a 450, that's one speaker, one amplifier. So the low impedance is a bit critical in that you need to do some few things. Number one, you need to know what is your amplifier impedance rating to the speaker's rating, and you also need to use cable that's appropriate. It's pointless. I've seen it happen. People take chances. They take a 0.5 square millimeter ripcord, and it connects to an amplifier that's pushing 500 watts into a load at 8 ohm at 500 watts. And somehow things started smoking, the cable starts smoking. It's like, let's get a thicker cable. So people do things haphazardly without even looking into what they are doing. So low impedance is very critical. You need to have the right cabling, number one, the right amplifier, number three, the right load. So it's all low impedance. High impedance is a little bit lenient, especially on cables, especially if you are running long cables or short cables, because most of the work is not done by the amplifier itself. It's done by the 100 volt that's picking up your signal and then delivering to each speaker.
And in fact, I keep on telling in all my orientations and training that the number one cause of death of speakers and amplifiers in churches,
Yes.
in houses of worship,
Yes.
is because all they care is the watts.
Yes.
They don't follow the impedance.
Correct.
So in most of the churches in Africa, not the professional ones,
Yeah.
but the mid-class and below,
Yes.
they go to the market.
Yes.
They say, I have 250 watt speakers.
Yes.
Let me get 1000 watt amplifier and I put 4 speakers on it.
Correct.
The only thing they forgot is the amplifier has 2 channels.
Yes.
Even if the amplifier is 2000 watts,
Correct.
they can only put 2 speakers on it. Even if the speaker is 250 watts, even if it's 500, even if the amplifier is 2, 3, 4,000 watts.
Correct. And
It's not about the load,
Yeah.
it's about the matching of the impedance.
Yes, and you have mentioned something that I've also found across in the industry. Very interesting. For us, I don't know what it is with our churches. They go and buy, like I've said, we had 2 speakers. Now let's add 2 more speakers. The moment you add low impedance speakers and you're connecting them in parallel, you are decreasing this impedance. If there are 2 4 ohm speakers connected in parallel, now you have a 2 ohm load. Does your amplifier handle a 2 ohm load? If we talk of class A, class B, class AB amplifiers, most of them, they handle only 4 ohm going upwards. If we go towards a 2 ohm load, you're asking for trouble. The amplifier is going to treat your load, your speakers as a short. It's going to burn out.
It's going to be like this.
Correct. Yes.
I'm tired. I can't handle. It's basically the same as we spoke about the previous episode about loading a full taxi people to a small car.
100%.
It can do,
Yes.
but not over time. It will just die. It will break.
100%. So people just connect things because all we want is more speakers. But is it necessarily the right way?
What happened there? Okay. So we broke out. We had a technical glitch. So some of the things of obvious were cut off, but we will continue from here. So as we were saying, basically impedance is the one of the most 3 important things when you buy a speaker.
Yeah.
And as much as you try and load, in the end of the day, it's not meant for it.
Correct.
It will die over time, even if it works.
Correct.
So basically, you'll find all of these people, especially in churches, but not only churches. Some people, even at home, do the same. And you load speakers to the amplifier.
Yes.
It works for some time,
Then it blows.
but not sustainable.
Correct.
Later on, it just dies.
Correct. Correct.
So it's funny enough, you mentioned two other things I wanted to talk about today. One, there are too many types of amplifiers.
Yes.
A,
Yes.
AB,
Yes.
B,
Yes.
D,
Correct.
analog,
Yes.
digital.
What are we talking?
What's the differences?
All right. So it's
In simple terms, as much as possible.
all right. So right when amplifiers were being designed or are being designed, there are three. Let me say one, two. Yeah, about 3-4 major classes. So we have what we normally call in our industry amplifier class A or class A amplifiers. So these are known for high fidelity sound reproduction, number one. But one of their weaknesses, they produce a lot of heat and they've got very low efficiencies. We're talking of efficiency of about 25%.
But wait, what is high fidelity?
So high fidelity is like high sound reproduction that's got very little or less distortion. So it's good, it gives you very good output, if I may say. That is what we are referring to as
Very good frequency response, a very good sound output.
yeah. So basically, in a nutshell, yes, a very good sound output. And then class B amplifiers is when the amplifier is in operation, instead of you relying on one transistor, as I'm speaking, I'm just trying to simplify it, is in relying in one transistor to push out or amplify the signal to the output. It uses two transistors. One amplifies the positive sign of the signal, the other the negative side of the signal. However, though generally class B amplifiers gives you about 50% of efficiency, they still produce heat, and they have what is called crossover distortion, because you are amplifying half of the signal by one transistor, the other half by the bottom transistor. In between that switching, they introduce what is called crossover distortion. So they produce high power in terms of amplification, but they come with a lot of distortion. And then what the industry did is revolve to try and resolve this. They combined a class A and a class B into one design. So you have a class AB amplifier. It gives you the benefits of the class A, high fidelity, the benefits of class B, which is high power, combined together. That's class AB.
More reliable?
Let's say yes, more reliable. Let's also compared to what you would get efficiency-wise on a class AB, it's rated around 60% of efficiency. Then, of course, there's something called class D. So class D, normally people are under the impression it's a digital amplification. It's not. It's just a class that has come up. It uses inside it, I will not go into the electronics, there's a circuitry called pulse width modulation. It creates some stuff to make a class D amplifier work much better. What happens with the class D amplifier? Number one, it's got a small footprint in terms of how it's built. It's very compact. It's very lightweight, high efficiency. If we talk of class A, 25%, class B, 50%, class AB, 60%. It's very possible to hit 90% of efficiency with a class D amplification. Very small footprint, very compact in build, and produces high power, high fidelity. All these other classes combined into one. So that's a class D amplification for us. So most guys have gone into class D because we have realized, look, a class B amplifier, when you're drawing more power from your electricity supply and producing only 25%. The rest is just dissipated or lost as heat. Class A, class B, taking 100% power from your mains. Okay, I'm just taking in layman language, and only producing usable out of your amplification 50%. Class AB, 60%. And class D, look, you are taking 100%, you are outputting back amplified signals at 90% efficiency roundabout. So class D amplifiers give you very high amplification power, very high efficiency in terms of consumption of power, as well as very low heat. So what you would need to cool down a rack full of class A, class B, class AB, compared to what you would need in heat dissipation
and class D, also known as digital in a way.
People always say digital, yes, so yeah, but otherwise they give you high efficiency, high power output, high fidelity as compared to any of these classes.
The old amplifiers, the A2000, before it was a D.
Yeah.
What was it, A or
AB.
It was analog?
It's usually designed around AB to combine both the advantages of the A and the B combined together. So most amplifiers in the industry will be AB amplifiers. But of course, you do have high fidelity of the old types that were class A. The reason why the industry doesn't take them on anymore is because they produce a lot of heat. But they were giving you high fidelity.
Not only that, I think we spoke about it today morning in the training.
Yes.
That an old amplifier, an analog amplifier, will weigh
Yes.
10, 20, 30 kilos.
100%.
And a class D is like a feather.
100%. Very well compared.
Yet I will think that this is fake
Yes.
because it doesn't weigh much.
It's
not much.
small.
It's
Exactly.
very light.
As you had brought in on the speakers, somehow in our continent, we are led to believe if you see a big amplifier, 5 guys lifting it, yes, that's serious power. No. A class D is just a small little one, as big as my cell phone. Put it in, it can push out more power than a class D, a class AB amplification. Thank you for that point, boss.
The other thing we spoke is, you mentioned it earlier, cable thickness.
Oh, yes.
So this is a big problem. And I learned a few years ago, I had a debate with my electrician that what they teach them here, I don't know if true or false, I've never been to the actual school, but I told him at some point, I want to see the teacher.
Yeah.
That when they say 2 times 2.5 millimeter, they mean the thickness of the cable from the outside.
All right.
And actually, it's the copper. It needs to be referring.
It's correct.
And the big problem in Africa, people don't like to spend big money on good quality things.
Yes, yes.
And unfortunately, if you go for a good quality cable, sometimes you'll find that the cable costs more than the system.
100%.
So how do you know? First of all, this is to all the consultants who do specification. When you do a 100-volt line system, there is really no need of 2 times 2.5 millimeter for 20 speakers of a 100-volt line, because in the end of the day, when will you use 2.5 millimeter on electricity? It's when you use the heavy load of KVAs.
Correct.
The same apply to speakers. If you are running total of 100 watts of power, 200, even 500 watts, you don't need 2 times 2.5 millimeter. 1 millimeter is enough. Even 0.75 millimeter is enough to run up to 1 kilometer, up to 100 speakers, even if need. So how do you know, or what will be the guidelines for speaker thickness? And then again, there's a disclaimer, because we have what we call the 100-volt line and the Pro Audio, the low impedance.
Correct.
And the Pro Audio, actually we have learned it recently from a project.
Yes.
The thicker, the better.
Yes.
So we have learned recently on our
project that we are doing now.
We cried over it because we didn't realize is that actually you need 2 times 8 millimeters of a distance.
Yes, correct.
But that's for the Pro Audio. So how do you know to somehow calculate what kind of cable will be best for you? And then again, we will also refer people, get good quality things, even if they cost more.
Yes.
Cheap is expensive. If you buy cheap, over time, things will die, will blow, will burn, problems.
Yes, yes.
So what will be your guide for cable thickness?
Look, cable thickness has always been an issue everywhere, especially when we are dealing with our content, especially when it comes to installations, people cutting corners, the thicker the copper, the more expensive it is, the good quality the cable, and the more expensive it is. But there is something called a cable calculator. Anyone can Google it. So what you normally do is when you input into the design tool, into the cable calculator tool, and you say, I've got an amplifier, for example, running at 240 watts, and you then put the speaker distances, it will then calculate for you or give you a guideline to say the cable that you can use for this specific amplifier and speakers is maybe...
Even for 100-volt line? Because what I found always on the calculators are for low impedance, mainly.
Yes, it also does. I've got one that also does on 100-volt line that I inherited from my seniors. It actually works very well. It just gives you a guide. So normally with thumbstack, I need a cable. He goes and buys a 0.5 square millimeter ripcord and he expects it to perform. It won't perform. So when you come to cabling, rather than just taking a guess and thumbstacking, I trust that you use a design tool for cables. Just Google cable design tool, whatever it is. It's a spreadsheet where you would put the input power, the distance, then it calculates for you roughly what kind of cable you must use.
Interesting. Some of the uniqueness things about TOA, that we forgot to mention or we didn't even go there, versus competitors is spare parts.
Yes.
You find it when you work with the cheap products.
Correct.
Spare parts the following month are not even there.
100%.
If the end of life, it's end of life, they don't even announce.
Correct.
How is it with TOA?
We do have a lot of spare parts for our products. There's some limits, to the limits when a product reaches an end of line, in most cases, we do have spare parts to support it for the next coming few years, depending, of course, on what product it is, and whoever also is looking for the spare product. So what normally happens when we are reaching an end of life, we normally distribute a letter to say, ladies and gents, we are coming to the end of this product. So those who have got that product already secured, they normally buy what we call critical spares. So there's a production of spares that still goes on for a limited number of years after the product has been stopped. So we do have lots of products that we have sold. Some of them have already been obsolete, but we still have spares lying around.
So basically, we can say one of the things with TOA pride on is the spare parts over years.
Yes.
I can easily say that at least 10 years we have spare parts for products after end of life.
100% correct.
Yesterday we spoke about IP systems.
Yes.
Today I want us to mention the active horn speaker.
Yes.
It's a bit different from the IP.
Correct. So the IP speaker that we were discussing yesterday works on IP, so you connect it to the same network as your NVR, and then you broadcast sound via the VMS back to the speaker directly, or that's the IP speaker. So we have also a self-powered speaker models. Okay, what happens with the self-powered speaker models? Obviously, you would need power to the speaker, and then you take your sound output from the camera. Normally, some of the cameras do have a line level audio output. This is where you would take your sound, plug it into the IP horn speaker. So whenever you're broadcasting or you want to broadcast to a specific speaker, you broadcast through the camera channel. So that we have self-powered speakers that works off 12 volts. And in SA, what we have also done, we have got self-powered speakers that are PoE, just power, PoE. So you plug them to the same network switch just to power the speakers, but the cable is directly connected to your audio output.
So on those speakers, we have beside the sound wires, they have power.
Yes.
So basically 4 wires.
Yes, correct.
2 for sound, 2 for power.
Correct.
And they connect from usually IP cameras have on the cables that come out of them, there's usually for audio out.
Yes, correct, boss.
And for power out, for external device. This is for actually for the speakers.
100% can be.
So I can be wherever I am in the country, over wherever I watch the camera.
Yes.
Either have a microphone or even from the phone.
Correct.
And I see my camera and I can tell that thug, get out of my premises.
You can.
Which kind of applications for this kind of horn?
I would say also like the IP cameras for the security industry, perimeter fencing, monitoring. Wherever you have a camera that needs a voice, we can supply you that voice.
Banks?
Can work as well at ATMs if you want. You have a camera focused there. You put an IP horn speaker, self-powered, gets its power from the same source as your camera, gets its audio signal routed through the camera, can also work.
Even farms up country, agriculture, when you want to watch your cattle, you're in Kampala and the farm is up country.
Yes.
You can do. And you can still trigger them automatically through the system? From the IP CCTV cameras, or
no? This will be direct routing of audio straight from your camera or NVR system straight into the horn speaker. It's slightly different to triggering message. These ones, the ones that are self-powered, don't come with a message built in, or you cannot upload messages to each particular speaker. They rely only on the audio coming from the camera.
So, for example, in banks, you can put it outside, and whoever is monitoring the bank, they see that somebody is coming in the middle of the night, monitoring, wants to rob the bank. Yes. You can tell the guy, we are seeing you.
Correct.
So they know there's always somebody monitoring, not just a fake camera.
100% correct.
Which other applications?
Besides this, I would say mostly it's for security that I've mentioned, and where can you other use it? Because normally you rely on something to route your audio, and this is normally done through your VMS system.
Another one is, which is not happening much in Uganda, but we have done a demo for police. Yeah. But you can do for the city, for security.
Yes.
You can connect it to normal cameras, and the city can now then monitor and then do an announcement, you left the bag unattended.
Right.
If somebody comes for the bag,
yes,
we know he really forgot his bag.
Correct.
If he doesn't come for the bag,
yes,
it means
something is wrong.
It's a bomb there.
It's a bomb there, yes, correct, indeed.
One of the unique speakers of TOA is the HX.
Yeah.
So a lot of people likes line array speakers.
Yes.
Now the HX is not a line array, but it looks like an array. What is it? What's unique about it? And we have 2 HXs. We have HX5 and HX7. You can see them up here. I'll put them here.
Yeah.
What is special about the HXs?
People say they are not line arrays, but I take them as line arrays, basically, because they direct sound to where you want it, depending again on the mounting, how you mount them. You can mount them at certain degrees, 0 degrees, 15 degrees, 45, 30 degrees, 45 degrees, 60 degrees, depending on the speaker type. And the most beautiful part about these speakers, they can work off without DSP. And if you introduce DSP into the speaker processing of the sound, then it gives a very refined frequency response. So the HX5, HX7s, they can work alone, and that produce a little bit of bass on the lower level, and they can work on very well with the mid-range and the top range, and also with the higher frequencies. And also, when you combine them with a subwoofer designed for the HX7 or the HX5 FB120 and FB150 respectively, with a DSP, you can then fine-tune the speakers in combination to give you the most optimal sound you can ever get from a speaker. So they are beautiful pieces of equipment with or without DSP.
And usually application for HXs, churches?
Churches, HX7s, HX5s, churches, stadiums, we've used them, large community halls, we've used them, wherever you want to throw sound over a wide space of people, like on the stadiums, you can cave them. If you hang them on the top, you can cave them so that the top end of the speakers fires on the top tire of the stadium. As the columns, you come down, you fire to the bottom end of the tires.
You can see a picture I've just put up here.
Awesome. If there's a picture that the boss has put up, you can put multiple. You're not limited to one. You can put multiple HX7 and you rig them with a special rigging frame from TOA. Rig them up, hook them up. You can have 4 or 5 HX7 forming a cave to literally cover wherever you want to throw sound. So
we even use them in Cape Town Airport.
Yes, we have.
The HX5s.
I think that was the HX5s, if I remember correctly. They were done by my colleagues in Cape Town. So we have actually had a very beautiful experience. I was with my colleague in West Africa in one of the churches. We put up 2 HX7s. The church was 30 meters wide and about 75 meters long. We hang them about 6 meters from the floor with the HFB 150s, the subs, lying on the floor by the pulpit. And those 2 HX7s on the left and the right were more than sufficient to drive that whole church all the way through to.
Now we talk about the Cape Town project. I remember that one of the challenges they had,
yes,
and I forgot to talk about it when you spoke about how you choose speakers.
Yeah.
And this is a word I've learned from Ralph as well sometime back. It's called intelligibility.
Yes.
This is not appearing on any spec sheets.
Correct.
But this is very important in order to compare speakers.
Yes.
Especially the cheap speakers. The intelligibility is very low.
Correct.
What is intelligibility?
So intelligibility is what basically the human ear would perceive when it receives sound from a specific speaker. Or again, if the speech is reproduced so poorly, I would not pay attention to the sound. So a crisp, clear speech done over a good set of speakers produces speech intelligibility in a nutshell. It's how the speaker relays the information that has been amplified to you and how you perceive it, that it is clear, you can pay attention to it. If I was going to speak, like mumble my voices, anyone would lose interest. So that's exactly speech intelligibility. If we both speak and we are arguing boss and we just go at it without giving each other time to talk, we create what we call, in a nutshell, speech intelligibility. The one who's listening is like, okay, so who's right? Is boss right? Is obvious right? What is going on? We are all shouting, and at the end of the day, the listener does not understand what we were speaking. That's speech intelligibility.
So intelligibility, in another way, is clarity of the sound.
Of speech.
To demonstrate, usually the way I do it, I talk like this.
Yes.
So when I talk like this and you can't understand what I'm saying, although you can hear me, but it's not as clear when I'm talking like this.
Spot on.
So this is how I usually explain intelligibility.
Spot on. I love that demonstration. Spot on.
So, intelligibility of speakers is very, very important.
It is.
And without being biased,
yes,
TOA speaker intelligibility is very high.
Very high.
If an expert wants to measure intelligibility, usually it's done with a special equipment that you feed into the sound system.
Yes.
With a specific sound that it feeds.
Yes.
And then you put a receiver on the other side.
Correct.
And it checks
yes,
the receiving point does it manage to capture word to word to the other device?
Correct.
That's how they measure. And usually I think it's ranked from 0 to 1, and 0.5 to 1 is clear. Below that, it's not clear.
Yeah, I think it's called STI. Is that correct?
Yes,
Yeah,
something
STI.
of that.
Yeah, something of that nature. Unfortunately, I'm not an expert on it.
No, 100%.
Yes, but
Same here. Yes.
Definitely true.
Intelligibility is very, very important in airports.
Absolutely.
And in gymnasium, but also in the house of worship. And
Yes.
we spoke about it as well in the morning, that in houses of worship, you come for two things and two things only.
Yes.
You come to hear
Yes.
the word of wisdom
Yes.
and to enjoy the gospel,
Correct.
not to be shouted at.
Yes.
And yet many churches or houses of worship, you go in Africa,
Yeah.
ha!
Yes.
Ha! Or they have speakers my size times 2.
100%.
And if you don't enjoy me shouting at you
Yes.
in the office,
Yes.
why do you allow the priest to shout? So they told us today, because it's a
Yeah.
house of men of God.
Yes.
They are holy. They can shout at us. It's not right.
It's not right.
You want clear sound in your church.
100%.
Yes, you want to have the oomph for the gospel to enjoy the music, but
Correct.
not to become deaf.
Correct.
You don't want to come out with your ears ringing after,
Yes.
because over time
Yes.
you lose your earring.
Yes. Again, just to briefly draw back from what we were discussing, we spoke again in the training, the difference between noise and sound. People were like, okay, what is noise? What is sound? Okay. Again, sometimes we go in there in a church or in a house of worship, let's just say a house of worship, and like you say, typical, you in there, it's like, okay, the sounds are pushed all to the maximum, and there's just about 25 people in that auditorium, and like, do we really need this? So there is a difference between sound and noise. So once we push everything up, there's distortion that comes through. You don't understand what's going on. It gives you what we were discussing earlier on, speech intelligibility. That's very crystal important in our industry. We need to have clarity of speech for us to be able to take in the message and consume the message.
Good. Almost the last subject.
No.
Power consumption.
Yes.
TOA power consumption versus others. I think one of the other most important things that people don't understand much about is they always look at the cost of equipment.
Oh, yes.
How much will that speaker and that amplifier? Oh, you are much more expensive.
Yes.
But I remember some time back I spoke about, Ralph mentioned,
Yes.
that there was a company in South Africa who has done a comparison
Yes.
about the power consumption, and they actually said that even if the equipment of TOA would cost 3 times more than competitors,
Yes.
over a period of 1 year,
Yeah.
they will still not be more expensive than the money they'll spend on electricity.
Exactly.
So, what is how can you explain a bit about the TOA efficiency in power?
Okay. So this is coming back to what we were discussing, how amplifiers are built, how much they consume, what they give out. So efficiency becomes a critical role whenever we looking at sound. So people look at sound and we only want the oomph. They don't look at the electricity bill that you've got to pay. So our systems are designed for high efficiency. They might be pricey when you buy them, but over a period of time, with what you would then pay to keep running the system, definitely we come in at a lower cost. So we have high efficiency on our systems that we have designed, and our amplifiers are super reliable. So again, you take all these factors in, which most people don't. People are looking, TOA is 15,000. No. This one is costing 2,000. But by the time you use that time to the lifespan of the TOA, you will have way exceeded what would you have saved when you've gone for the TOA.
The way I always explain it,
Yeah.
To people, because they understand other products.
Hundreds.
So I always give the example of power saver bulbs.
Mm-hmm.
Many years ago, they used to buy bulbs of 100 watts, very
Yes.
cheap, and then the power saver came.
Yes.
But people say power savers are expensive.
Hundreds.
But the government educated the people, buy power savers, you will consume less power.
Yes.
So in the end of the day, the bulb costs 3 times more in halogen,
Yes.
but in the electricity bill,
Yes.
you pay a fee for 6 or even tenths of the price
100%.
on the electricity bill.
Yes.
Just before we summarize, we spoke about training downstairs. We have done today, we have done yesterday. We're always training.
Yes.
If people who are watching us or listening to us wants to get training
Yes.
First of all, TOA offer free training
Correct.
to anyone who wants to do training or to understand sound
Correct.
and the TOA systems.
Correct.
I believe there are 2 academies.
Yes.
One in online, they are both online.
Yes.
One the European and one the African.
Correct.
That is in South Africa.
Yes.
The European is more orientation about the product.
Yes. Sales,
the features
sales
and
marketing. Yes, correct. And the one that's in South Africa that we run and do is actually more technical. You would, of course, get to log in as a user, and then you take in your studies, pay any product that you want. There's about 17 live courses now, and I've got about 90 or so users. So per every month, let's say, you can log in. I can have users as about 100 trainees online. So all you do is you register on the portal. You get your username and password from the portal emailed to you. You then take a course that you want. The beautiful part, I've done these courses in a manner that if you go through each chapter of the course, it's exactly as if you are sitting in front of the manual and opening the pages on the VM. So there is hardware courses for the VM, there's software programming courses. So what I've done in the courses, I've done video chapters on each and every icon or a tab of the programming. So you start with me right on the beginning of the course, you go through the course together, you follow, mimicking what I'm doing, copying what I'm doing on your laptop. By the time we come to the end of the course, you have already configured a perfectly working system. So we do this, it's an in-depth technical training, and we have got about 17 courses that are running in there, all of them free of charge.
So you can find the links for both the European Academy and for the African Academy at the description of the video, or you can contact us, find us,
Yes.
comment, and I will share those links and addresses. In any case, you can find us on Twitter. You can also find TOA Africa on YouTube, also lots of courses there that we have done.
Correct.
Thank you very much for today.
Absolutely a pleasure,
It
boss.
was also good, a bit lengthy today, but I hope we are managing to deliver to the consumers that, once again, a good consumer is an educated consumer.
Very indeed, very true.
And we're trying to empower
Yes.
our consumers so they know how to buy better.
Correct.
So not just us saying TOA is better. If you go on the spec sheets,
Correct.
you will actually be able to see
100%.
the ability of TOA.
Yes.
Thank you very much. And maybe another episode tomorrow. We shall see.
We shall see.
Have a good day, everyone.
Thank you. Bye-bye.